case, we got problem number 5. It says the following. There's a landfill that starts in year 2010, which makes time equals to 0. This is when time equals 0. And they give us the derivative of a function w, dw over dt, which is 1 over 25 times w minus 300. This function applies when t is from 0 to 20. So from the year 0, that is 2010, 10 years forward, it will apply this equation to the rate at which the landfill increases of tons. As you see, W is measured in tons. And it is said also that W of 0 of the original function is 1,400 tons. And a fact is that the function W is differentiable, and it is implicit that it is a function of time.
In the part A, we are asked to find an approximation with a tangent line at time equal to 3 months. So time equal to 3 months is equal to 1/4. So to get the tangent line, we use the derivative to get the slope, and then we use the point slope equation to find the linear equation, the linear tangent line. So the derivative when t equals 4 of 1 over 25 of w when equals 0, because the tangent line needs to be an approximation, a Newton approximation when time equal to 0, minus 300. So the approximation when the amount of waste at the landfill is when time equals 0, it is 1,400 tons. So we get that the slope is 44. Then we substitute in the point slope equation, and we get that the equation is y equal to 44t plus 1,400. So we evaluate the 3 months. This is 1/4 in the tangent line equation, and we get that the approximation when time is equal to 1/4 is 14 and 11. In the part B, we are asked to find the second derivative of w. So the first derivative is 1 over 25 times w minus 300. We get that the second derivative is 1 over 25 times the first derivative of w. So we get that it's 1 over 25 times 1 over 25 times w minus 300. So as w is always bigger than 1,400, we get that the second derivative is always going to be positive. So the w of t has a positive concavity, so the second derivative needs to be under the curve of w of t, and we get that the value that we got in part A, it's an underestimation. In part C, we are asked to find the function w of t, and to prove that it is equal to this with the initial condition that when time is 0, the tons are 1,400. So we first pass the dt to the other side and the w minus 300 to the dividing the dw, and then we integrate those parts, and we got that the integrate of this is ln of w minus 300, and the integrate of this is t over 25 plus c. So to get c, we need the initial condition w of 0 is equal to 1,400. So we get that ln of 1,400 minus 300 is equal to 0 over 25 plus c. We get this because w of 0 is 1,400 and t is equal to 0. So the c is equal to ln of 1,100. So then we substitute the c on the equation, and we get that w minus 300 is equal to e to the t over 25 plus ln of 1100, and then we pass the 300 to the other side and separate this this exponent and this other exponent is making an addition, and we get that w is equal to e to the t over 25 times e to the ln of 1100 plus 300. So the function w of dt is equal to 1100 times e to the t over 25 plus 300.